Hello and welcome to The Daily Space. I'm your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put, as always, science in your brain.
Today is a jam packed day. Not only do we have all that is new in space and astronomy, but we will also be joined later in the show by Fraser Cain, the publisher of Universe Today, to talk about the changing landscape of space news. For now, though, let's jump out to look at a big galaxy in the Hubble Deep Field.
As we head into year 2 of pandemic lockdown, I for one know it's time to buy new yoga pants in maybe a size larger. Let's face it, sometimes things just grow. But before any of us should start to feel bad about our personal mass enhancements, we just need to put everything in perspective. No matter how many random Oreos I may eat, my gains are insignificant compared to those of galaxies in the early universe. Back in 1995, the Hubble Space Telescope pointed at what was believed to be one of the blankest regions of the sky. It looked at that patch for 10 days. The goal was to see just what faint objects might be out there, otherwise lost in the light of all the nearer or brighter objects. The answer was galaxies. This tiny field contained over 3,000 galaxies. And one of those galaxies, HDF 850.1, is a massive star-forming system 12.5 billion light years away. This galaxy is putting on stars at a rate of a few hundred solar masses of stars per year. This is the highest known star formation rate ever seen. A new paper by Rosie Calvi and company, appearing in monthly notices of the Royal Astronomical Society, looks at the environment around HDF 850.1 and finds 23 observable companion galaxies and a complex structure around it. These systems are thought to be just the brightest members of a massive galaxy cluster forming in the early universe. Over time, these galaxies will interact and move together to form a cluster that, if we could see it today, it would probably look a lot like the nearby Virgo cluster. Put another way, this massive system is so massive it has gravitationally pulled in its neighbors while spitting out hundreds of stars a year. I suddenly feel much better about my personal growth over the last year.
From massive galaxies, we now turn toward massive stars and an easy sounding problem that has turned out to be quite hard. Also, this research article came with a really pretty picture we wanted to share. Long story short, researchers have been struggling to find ways to accurately measure the temperatures of red giant stars like Betelgeuse in a consistent manner. These stars have complex atmospheres that are highly variable, and many of the normal ways we have for measuring a star's temperature don't work so well with that chaotic atmosphere. We need to know stellar temperatures, however, to make sure our models describing how these stars live and die as violent supernovae are correct. Well, iron has come to the rescue. This particular atom can be found in the outer parts of stars and is highly sensitive to temperature. Like all atoms, iron absorbs light at specific colors, and how much light it absorbs at each color depends on temperature. By comparing how much light is absorbed at different colors, researchers from the University of Tokyo have been able to accurately measure the temperatures of red giants and determine that theory and reality match nicely. As for this stunning image, that red asterisk of light is the star Betelgeuse. Next time you look at the constellation Orion, know that the entire region is rich in these clouds of star formation, and the stars we see are just the brightest sampling of what's out there.
What we see with our eyes is just the faintest tracing of everything going on in the sky. And it's often the accidental discoveries that are the most memorable. Recently, researchers using the Juno mission's ultraviolet spectrograph were purposefully observing aurora around Jupiter when they accidentally observed a bright meteoroid explode in Jupiter's atmosphere. The explosion took place about 140 miles above Jupiter's cloud tops, and its brightness was consistent with an object between 550 and 3,300 pounds. Basically, a car-sized rock exploded above Jupiter and was caught on camera in the process by accident. We used to think these kinds of events were rare, with the 1994 impact of Shoemaker-Levy 9 into Jupiter being the first broadly observed impact. We're now learning they aren't so much rare as generally brief in duration, and unless you happen to be watching Jupiter at just the right moment, they tend to go unnoticed. Remarkably, most impacts like this are spotted by amateur astronomers. You never know exactly what you could discover by looking up.
And sometimes you have to look down to understand what you might someday find when you look up. Researchers from the University of Rhode Island's Graduate School of Oceanography have published a new paper in Nature Communications describing how life living beneath the seafloor can survive off chemicals released through radioactive reactions. Specifically, naturally occurring radiation can split water molecules into hydrogen and oxidants, and this process is much more effective in seafloor sediment than in open water. According to Stephen Daunt, a co author on this study, if you can support life in subsurface marine sediment and other subsurface environments from natural radioactive splitting of water, then maybe you can support life in the same way on other worlds. Some of the same minerals are present on Mars, and as long as you have those wet catalytic minerals, you're going to have this process. If you can catalyze production of radiolytic chemicals at high rates in the wet Martian subsurface, you could potentially sustain life at the same levels that it's sustained in marine sediment. As a reminder, marine sediment is extremely rich in microbial and other life, implying Mars could be rich in tiny life forms just waiting to be found. Percy, we're looking at you. Please go find fossils of past life that will let us know if we should go looking for current life. After the break, we'll be back to talk about the Trojan asteroids, and we'll have an interview with Universe Today publisher Fraser Cain on the changing landscape of science news. Stay tuned. Our next story is one for both the astrophotographers and the planetary scientists, but not for Pamela, because I'm going to discuss a mission that hasn't launched yet. That mission is Lucy, which is a NASA Discovery Program mission to explore 7 Trojan asteroids and a main belt asteroid. It's a 12-year mission, and the launch window opens up on October 16th of this year. So, what are the Trojan asteroids? How did we find them? Here is where the astrophotography comes in. In the late 1800s, German astrophotographer Max Wolf had already made a name for himself at the ripe old age of 21 by discovering his first comet. At 27, he decided to search for new asteroids using wide field photography, the first person to attempt such a feat. Within 2 years, he had found 18 new asteroids. After that, he became the first person to use a stereo comparator, which is like a viewmaster, that helped make those asteroids more easily visible against the background of stars. Then, in 1906, Wolf found an asteroid with what appeared to be an unusual orbit. It remained ahead of Jupiter as Jupiter moved. Another German astronomer, Adolf Berberich, confirmed the discovery and noted that the asteroid's orbit was about 60 degrees in front of Jupiter. And here is where work by Joseph Louis Lagrange comes in. I'm sure a lot of our regular viewers are familiar with Lagrange points, but let's give a quick summation for those of you who are not. Lagrange was a mathematician who theorized that a small body, like an asteroid, could be caught in the same orbit as a planet if it ended up at one of 2 stable points in that orbit, what we now call the L4 and L5 Lagrange points. Essentially, at 60 degrees ahead or behind, the smaller body benefits from the combined gravitational forces of the planet and the sun. If you could stand on Jupiter, these asteroids would look like they weren't moving. Up until Wolf's discovery, Lagrange's work was purely mathematical. Now astronomers had photographic evidence. Within a few months, 2 more of these Lagrange point asteroids had been discovered by other astronomers. And now that there were several, it was time to give them a name. Remember, Astronomers like objects to fit into boxes, and then we name those boxes. Most of the asteroids in the main asteroid belt have been given the names of women from Roman and Greek mythology. Think Ceres or Vesta. So, Austrian astronomer Johann Palisa suggested that these new Jupiter asteroids be called Achilles, Patroclus, and Hector after characters in the Iliad. And so a naming convention was born. But not quite. Here's where the story gets fun, and I'm going to quote a NASA article because it's perfect. As astronomers continued discovering asteroids hiding in Jupiter's Lagrange points, they continued naming them after heroes of the Trojan War and began referring to them as Trojan asteroids. Trojan asteroids would eventually refer to asteroids inhabiting any planet's stable Lagrange points, though names from the Iliad are reserved for Jupiter's Trojans. It later became convention to name Jupiter's L4 asteroids after Greek characters and Jupiter's L5 asteroids after Trojan characters. So L4 and L5 became the Greek camp and the Trojan camp, respectively. Palisa apparently did not foresee this tradition, for his naming of the first three asteroids led to a Greek spy residing in the Trojan camp, Patroclus, and a confused Trojan, Hector, who probably wandered into the Greek camp hoping to order some of their famous custom built wooden horses. These Trojan asteroids are thought to be the remnants of the material from which our outer planets formed. Some resemble icy bodies found in the Kuiper Belt, some resemble main belt asteroids. All are thought to have an abundance of dark carbon compounds, as well as an insulating blanket of dust that covers a wealth of water and other volatiles. Now, for the first time, we are sending a mission to study some of these Trojans, including Patroclus. The Lucy spacecraft is named for the skeleton of a human ancestor whose discovery led to breakthroughs in our understanding of human evolution. The spacecraft is expected to do the same for our understanding of planetary formation and evolution here in our solar system. After Lucy's launch, the craft will use boosts from Earth's gravity to travel between the L4 and L5 Trojans, targeting 7 asteroids in total, including one main belt asteroid, Donald D. Johansen. The initial mission will take 12 years to complete, and after that, Lucy will continue to cycle back and forth between the 2 points every 6 years. We're excited for this launch, and we'll keep you up to date on the timeline here on Daily Space. When we return, Pamela will be joined by Fraser Cain, publisher of Universe Today, to talk about how science news is changing.
Hello, everyone, and welcome back. I am now joined by my longtime co-host of Astronomy Cast, Fraser Cain, publisher of Universe Today. How are you doing today, Fraser?
Very well. I'm enjoying watching somebody else report space news. It's great.
So I was trying really hard to figure out how best to introduce you. And I had the realization in the process that you have been communicating space news online since people actually weren't ashamed to have AOL accounts.
Yeah, 21 years.
So your Universe Today site dates back to the days of dial-up, and you have been here to see the transformation from the majority of media coming to us here on television to the majority of news coming to us on the internet. And
Social media now.
yeah,
Yeah.
and where we get news has radically changed. How we turn up stories has radically changed. And I'm hoping that you can start off by saying what it was like back in those early days of the internet and how things have changed over the years. So how did it start? What brought you to this Babylon 5 named behemoth of space news that you are today?
Well, okay. I think people know my origin story fairly well. The domain name, even back in 1999, there weren't a lot of domain names available that were good. And so I just took all of the space names and all of the time domain names, put them together one after the other, checked them all against available domain names and bought the one that I liked the best. So it could have been Cosmos now, but it ended up being Universe Today. So there was no There's no rhyme or reason to the actual name, and I learned later that it matches the newspaper in Babylon 5. But hopefully, I have been using it long enough that it's been clearly mine as well. How I got into it, I used to work as a web developer for a big company in Vancouver. We were doing banks, hydro companies, lottery, discount trading houses, fairly big and institutional clients. And I had a lot of wacky ideas, which Pamela can probably confirm all the time. And nobody would listen to me. And so I said, okay, well, you know what? I'm going to build my own website. I'm going to practice all of my wacky ideas, see which ones are good, which ones are bad, throw out the ones that don't work, and apply the ones that work to my clients. And it worked like a charm. I, developed Universe Today, picked one of my hobbies. I happened to be reading Pale Blue Dot and The Case for Mars at the time, had been super into space all my life. And so I said, okay, I'll do a website about space. Learned a ton about running a website, that it's not about building the website. It's about day after day after day showing up and keeping things fresh and updated. And I brought all these lessons back to my clients, but I also said, okay, I'm only going to do this for the rest of my life. Like I'm having so much fun that now it's a question of when can I escape the rat race and when can I just do Universe Today forever? And, we were able to live cheap, do some advertising, live off some of our savings, and I was able to go it alone. So that's been, and like I said, I started the site in 99, probably went full time, or probably cut the chains in like 2001, and I think I've been earning a reasonable living from it since maybe 2005. Brought on more people by 2007, 2009, and now I think we have 15 plus writers on Universe Today.
And how we keep track of what all is going on in the universe has radically changed in those years. You have been around for the emergence of social media. You've been around for the emergence of new media, which actually came out in the opposite order.
Yeah.
And it went from news was what you got in press releases and from looking at the journals to news is what some random grad student is excitedly tweeting about as their team publishes a paper.
Yeah, absolutely.
What have you had to take into account as you change to follow where the stories are?
Well, when I started, all of the big media companies had either a specific space reporter
Yeah.
or a science team that was capable of reporting on big space news. They would send people to the Cape to film space shuttle launches. They were at big press conferences for the Hubble Space Telescope. They were at NASA for, there was a lot of coverage in old school media. So I started really just covering what they were covering.
Okay.
And so I would, if ABC was reporting that some interesting piece of space news had happened, I would report that ABC News was reporting this. And then I said, okay, well, how do they know? How did they learn this? And so then I would follow these to the source, because they would say, oh, based on a press release from this university. I'd be like, oh, okay. And then I would go to that university. I would see the press release and I would go, okay, now I can just follow the press releases from this university and find out how this is being done. And so within a couple of years, I was able to get past all of the middlemen and get to the source of most of the news. But then every now and then someone comes up with something that you haven't seen before. And you're like, wait a minute, how did you know about this interesting piece of research? I'm like, oh, it was in a paper. Okay, now I have to understand where all the papers come from. And so I found AstroPH and Astrophysical Journal and all that, and check all those. And that takes you sort of way closer to the source. But still, things would be happening that I was like, where did this come from? Because it was announced at a conference or announced at at some get together. And so I would then now start to troll all of the conferences, all of the different papers, all of the different keynote speakers, what they were going to be saying, and be able to digest and incorporate that. And so about, in the rise of Twitter, was the first time there was sort of like a new source of interesting stuff was finding its way into the newsfeed, and I had no idea kind of where it was all coming from. And that's a much trickier one to sort out, because you can have Elon Musk post on a tweet that they've got an idea for a brand new spaceship, and there's not going to be any press release that covers that. So in the modern age, now that I sort of look at all the press releases, I look at all the journals, I look at all of the conferences that are happening, and then I have to layer on top of that, what's the chatter? What's the interesting things that people are talking about? And my goal is to get there and find the stuff that nobody is aware of, nobody's thinking of, and that there's really no coverage of. That's, like, I'm less enthusiastic to talk about Perseverance landing on Mars, not because I'm not stoked for Perseverance. And we did, I think we're at 5 or 6 or 7 stories so far about Perseverance on Universe Today so far, just after the landing. But I know it's going to be well covered. I feel like Perseverance's story is being well told. I'm interested in the people that are building robots made of ice. I'm interested in the people who are planning on building telescopes out of local materials on the backside, on the far side of the moon. So my job now really is to just dig into every nook and cranny of the science that's going on and reveal the stories that are fascinating to me, that I think are important, that I think are getting less covered.
That is amazing. And when we come back from break, we're going to talk more about how it's possible to take a ragtag group of baby journalists and turn them into one of the, well, powerhouses for astronomy news. So we'll be right back. Stay tuned. Hello and welcome back to those of you just joining us. My name is Dr. Pamela Gay, and I am joined today by the publisher of Universe Today, my collaborator of many years on Astronomy Cast, Fraser Cain. So we now live in this amazing work from home environment that you and I have actually been doing for forever.
Doesn't feel any different.
Exactly. And I feel kind of like we're designed for these crazy modern times that we live in. And you're showing how you can work without any buildings, without any art department, with a group of humans.
Yeah.
At what point did you realize you could take on the big publishing?
Well, I had always assumed that big publishing was going to take on itself and wipe itself out of existence. So I never felt like it was my job to take them on. I could see that as they laid off their science reporting teams, as they focused more and more on clickbait, on a very surface level of understanding of the kinds of things, that they were making themselves more generic and not really setting themselves apart from anyone else. And that could work for a few people. It could work for the New York Times, it could work for the Washington Post, but for the large part, it's not going to work for most of them, that they're going to get to the point that they really just don't understand the stories that they're working on. So I had assumed from day one that the dominant role of traditional media was temporary, and that we were going to shift to new media being the dominant role. I just didn't think it would take this long. Right? Like I thought it would take like maybe 5 years, right? Maybe 6 years. Like we get to a point where like, yeah, okay, people take their news seriously from the internet. But here we are 21 years later, and still people take CNN. People are more interested in hearing from CNN about space news than me. So I see that I need to just keep holding on. So my job is not to take other people on. My job is to not die, to not like be, I'm like I don't know.
You're
like
the mouse waiting
kill.
for
I'm
the
cockroach.
dinosaurs to be done.
I'm a cockroach. I am unkillable. And so because I run Universe Today. Literally, I run Universe Today from a corner of my basement. The entire team is online around the world, set up wherever they want to be. We work completely virtually, and our expenses are, the price of the heat and my internet and what it costs to keep me in new computers. So it's, in terms of just like our expenses, we couldn't go lower in terms of operating expenses. And so I think that allows us to then just wait patiently for what we all know was inevitable,
Yeah.
just that it is taking longer than anyone ever expected.
And I feel like it's going full circle. As we record this episode, it will be airing tonight on Houston Now Media 21.10 because apparently television stations now have dots. Um, and and here we are taking what was an audio only podcast that ended up with video getting added, that ended up getting picked up for television in the opposite direction of where things started when you and I first began doing new media. And we found all these radio shows and TV shows joining us in the podcast
Yeah.
directories. And we're putting out our Astronomy Cast show with a staff of 2 part-time humans and then the 2 of
Right.
us.
Yeah.
And Daily Space, there's a whole whopping 4 of us involved in putting it
Ooh, yeah.
together. And
Yeah.
there are more camera humans on most news shows than we have total humans.
Yeah. Yeah. I mean, the infrastructure is like, I want to spend all my money in paying writers to write interesting stories. I want to spend every single penny that I have to spare on news.
Yeah.
And I don't want to spend any money on fancy gear. I don't want the gear to make it worse. But beyond that point, I don't really, it doesn't really bother me. So how can I get the most news possible and the best coverage and really kind of specialize on that? So yeah, no, I think it's, there's just like an existing infrastructure that a lot
Yeah.
of these old media companies have. They have offices in Manhattan. They have studios. They have ways that they do things, and that has never been affordable for us in new media ever.
Right.
And I don't think ever will. Like, unfortunately, I think that the way we run things is the future for most things, because we're moving away from mass media and moving to a very specialized kind of media where people are really interested in a certain kinds of topics, certain kinds of things. There's people who do a great job in that area. They support them through advertising, through being patrons, through
Yeah.
sponsorship and that kind of thing, so that they're able to continue doing their job, and less so just having more generic information just be playing in the background while you're doing other things. So I think people now choose their media very carefully, and those who are able to stand out will do well.
One of the things that I kind of love is we've had the opportunity to go to a few different launches, and we show up with backpacks of equipment instead of news vans with satellite dishes. And
Yeah.
this gives us the freedom to run around and cover anything from anywhere, which is kind of amazing. But I don't know about you, I'm watching what the new kids on the block down at Boca Chica are doing,
Yeah.
covering. Who do you look for now for inspiration as we get older to make sure that we don't end up being old media?
Yeah, exactly. Yeah. No, they're doing amazing. I mean, you look at what's happening with Everyday Astronaut and
NASA space flight.
NASA Spaceflight is doing an amazing job. Yeah, they're doing they're doing a terrific job. And I mean, partly they have the advantage of being Americans. I'm a Canadian, so I can't even come into your country right now. But I do have partnerships. I mean, we send a photographer to most big launches. We're able to have local photographers who can attend launches at Cape Canaveral and stuff. But there's just like a level of dedication and live coverage. And I'm so grateful for the work that they're doing and the quality of the coverage, and that the benefit that they're giving me is that they are helping to raise the overall knowledge and understanding of the current level of space flight and space exploration, to bring whole new communities into this entire field, get them excited about what's going on, and then people will be looking for other stuff. And yeah, I can't provide a live stream coverage of the latest SN flight, but I can tell you why it's important. We can cover all of the follow-on technologies, all of the other interesting stuff that surrounds it, and probably a bunch of stories that you've never heard. So I think that anything that really just raises overall awareness of what's happening in space and astronomy is just more, please. I mean, you and I we've always held to this, that
Yeah.
the more people who come into this field, the more people that come into this community, the better it makes the community. There literally is no such thing as competition. I I don't even think about it. I'm just super excited, and I help them out every chance that I get,
A-
both Padre and Everyday Astronaut and NASA Spaceflight and Ars Technica. They're doing a phenomenal job.
We're not doing this in competition. We're doing this in celebration of one another's achievements. And that's one of the really awesome things. So, what's the next big thing that you're coming out with that people should know about?
Uh, hmm. I, I sort of have shifted away. I don't really have a lot of big projects that I'm working on right now. I mean, I think the pandemic obviously has sort of changed our what we're capable of accomplishing
Yeah.
from the confines of our house and the borders of our country pre getting vaccinated.
Yeah.
I think once things are lifted, there's a lot of like interesting reporting and road trips and things like that I would really love to do. There's a lot of missions, a lot of places where interesting work is getting done that I'd love to be able to try and take the stories there. But beyond that, I mean, the big thing I'm working on is keeping my family safe, me safe, the website safe, keeping as many people as employed as I can, and helping everybody weather through this situation. That if we get through this and everybody is at least the same, maybe mildly improved, then it's a tremendous victory.
I think that is a fabulous note to end on. It's been great having you here, Fraser, and we will be recording live on YouTube this Friday at 3 p.m. Eastern. And new science coming daily, weekly, and apparently for decades in the decades to come.
Yeah.
So this has been the Daily Space. If you want to learn more about all the stories that we've presented today, check out the images and get links to all of Fraser's sites. Check out our website, dailyspace.org. Thanks, everyone.